All right, go ahead, take a look up here, guys. We're gonna zone in on this factoring of a trinomial when a does not equal 1. That's the key here. So, see, we got to be able to approach this with a methodical way, where it's easy for us to do. And here, I want you to circle this, guys. When a does not equal 1, this is critical. Okay. See, when a doesn't equal 1, we use this method. It's called the divide and slide. Divide and slide. And this method was derived in Singapore. Okay. But really, what's nice about it is it works 95% of the time. Okay. There's unfortunately just a few cases in which the method may produce a slightly different result. But in most cases, you're going to be just fine with this method. Okay? So the thing I want to stress first of all, though, is in any standard form polynomial, okay, if you can factor out a greatest common factor, you always want to do that first, no matter what. See, on Monday, when we factored those tries, none of those had GCFs. So you could easily, use that factor the C that make the B and factor it, right? But if you ever have a greatest common factor on the left side, you always want to do that first. Okay? So that's important to see. So here we go. Let's try this out here, guys. Look at example 1. We're going to factor this trinomial. We're going to produce this. It's in what form is that guy in, first of all? Standard. And we want to produce what? Intercept. Okay? So the first thing we got to do is investigate the numbers. All right? You have to ask yourself, is there a greatest common factor between all three terms? There's not. So we're good there. See, we got to remember GCF first, no matter what poly I see. Okay? Now, if that's the case, let's label the A, B, and C. So A is 3, B is 7, and C is negative 20. The only thing you do that different this time is you want to make the A 1. To do that, you actually multiply the A times the C value and make it a new polynomial. Okay, everybody see what I just said? Yeah, so I'm going to rewrite this as x squared plus 7x minus 60. Okay? So in other words, what you want to do is try to produce what we had on Monday. All right? You want to produce a poly with A being 1. See, the 3 doesn't disappear. We just multiply it by the C to make that C term larger. So that's the first step. Okay? Then we factor like we normally would. All right? So now what factors of 60 make 7? 12 and 5. Very good. So you got 12 and 5 in the ends of the binomials. What's the only way to get a plus 7 from those two numbers? Plus 12 minus 5. Bingo. So that's what we did on Monday. But here's what you got to remember, guys, and this is the part students always forget. Okay? See, since I multiplied by 3 in the beginning, what do I got to do at the end? Divide by 3. Okay? It's not mathematically sound, but it always works. 95% of the time. Okay? So here we go. See how we times it by 3? So what we do is, at the end, you divide each by 3. Remember to do that. All right? That's such an important step here. Because what happens now is, and this is where this is mathematically unsound. Okay? Technically, you see how this 3 is really divided by both of those? We actually just ignore the first term and just focus on the last terms. That's where it's mathematically unsound. Okay? So if I circle these last terms, and we want to see if they can simplify, right? So what's 12 divided by 3? So this by becomes x plus 4. Okay? So that's the trick. See how this divides, that becomes 4. But then the question comes up, well, what if it doesn't divide out of it? This is why we call it divide and slide. See, I divide, it doesn't divide out nice, so the 3 slides in front of this x. Okay? So they call it slide because this doesn't come out nice, so I'm going to put it right in front of this x. So your final answer would be x plus 4 times 3x minus 5. And you're done. Okay? So that becomes our intercept form of that parabola or that quadratic. Okay? Now, here's what I want you guys to be thinking about. How do you know this is correct? Well, let's be a little more specific. See, that's the intercept form. How do you go from intercept back to standard? You FOIL it back out, right? Let's FOIL it out in our heads. First terms, 3x squared. Outers, negative 5x plus inners, 12x, right? So what's negative 5 plus 12x? That's your 7x in the middle, right? And then what's the last term multiplied to? Negative 20, bingo. So it produces the original standard form that you started with. If you factor it right, you could FOIL it back out to what you started with. Okay? So let's try another one here. Here's a trinomial. Okay? And I want you to ask yourself, is there a GCF? No. So that's good. Let's label the A, B, and C. So A is 5, B is 13, and C is 6. Okay? All right, here we go. How do we get rid of the 5 out front? So what did we do on the last one? You multiply it by the C. So you make it a new problem. So it becomes x squared minus 13x plus 30. Now the A is 1, and now we can factor that thing just like we did on Monday. All right, here we go. You guys tell me the magic set of numbers that makes a negative 13. Or 15 and 2. All right? But there's only one that's actually going to work. No. See, here's what you got to be thinking about, guys. See, some of you told me 10 and 3. Some of you told me 15 and 2. Let's find out which one it actually is. All right? So you got x and x. Let's try the 10 and 3 first. So let's say we had 10 and 3 right here. What's the only way to get a negative 13? Minus. And then what you got to ask yourself is, if this is the magic set of factors, it has to FOIL back to what it started to, and it does. Because what's the last terms multiplied to? A plus 30. See, why would negative 15 and plus 2 not work? It'd be negative 30 for your last terms. All right? That is an important algebra skill, to recognize which set of factors is correct. Okay? So, all right. Now, you guys tell me now. I multiplied by 5 in the beginning. So what do I do at the end? Divide by 5. Very good. So just divide each by 5 at the end. And then circle the last terms. That's all you want to focus on. Okay? Now, something we want to make sure we always do here. Okay? So what's 10 divided by 5? Okay. So another thing to consider before you divide and slide, another way to look at this is, see, these guys reduce, right, to 2 over 1. It's another way to look at it. All right? So obviously this guy is just x minus 2. Okay? This guy right here, see, the 5 doesn't come out of 3 nice. So where does it slide? So where's the 5 slide to? In front of the x. So this guy goes right here. So notice you'll get 5x minus 3 is your second bind. Okay? Alright, let's see if this is right. We're going to FOIL it in our heads. Okay? First terms. Outer terms. Plus your inner terms. Produces a what? There you go. And then what's your last term multiplied to? 6 plus 6. That's how you know it's right. Okay? Alright, on your own. Here we go. Try letter C, please. Try that one real quick. Show me that you can do the divide and slide method. Okay? Kind of a cool method, guys. It works. And it's an easy way for us to not be guessing and checking things like that. Okay? There you go. All right, seeing some good steps, guys. A good check in the right direction here. All right. Raise your hand if you got those two buys, please. Okay. So the key here is, you guys tell me why I got x plus 1? That reduces. How did I get 2x plus 7? 2 doesn't come out of 7, so it slides in front of the x. Very good. All right. Phenomenal. Let's take a look at a few others here. Got to see different versions, guys. Okay. So here's another one. We got a trinomial, no GCF. Nothing comes out of all three, so we're keeping that in mind. All right. So the A is 9, the B is negative 12, and the C is 4. So label those first. Okay. All right. First step. Okay, so what do we get there, Waylon? Very good. And that would be plus 36. Now we factor that trinomial when A is 1. Emerson, can you tell us what that tri factors to? So what are the factors of 36 that make negative 12? Well, what goes into 36? Well, we gotta, well, let's, careful, no, that's 32. Factors of 36. That make double negative 6 is very good. All right. So notice you're going to get minus 6 for both guys. Very good. Okay. So that's important to see. Hey, those are the factors that make that middle term. Excellent. Then I divide by what I multiply by. So divide by 9 here. Now, this is important. Okay, we haven't seen this yet in our problems. See, when I get to this step, right here, 6/9 is not reduced. You always want to reduce the fraction before you slide. A lot of students want to slide first. So you got to be careful. Okay? So what you do is you take 6/9 and you make it what? 2/3. Okay? So we got 2, 3, 2, 3. Now, since this 3 doesn't come out of 2, what does it do? It slides. So notice you'll get 3x minus 2 times 3x minus 2. And that should be our correct answer. Okay? Now, let's check it. First term is multiplied to what? 9x squared. Right? What do my outer terms become? Negative 6x, right? What are my inner terms? That adds up to what? Negative 12, right? And then what are my last terms multiplied to? Plus 4. I'm going to show you guys a little trick with this one. Okay? See, whenever you have the first and last terms of a trinomial, and you notice that they're perfect squares, all right? So this guy is actually a special type of polynomial. This term and this term are perfect squares. You don't even have to do all that process. See, it turns out that if you square root both of these terms, what's the square root of 9x squared? A 3x. So that's how you got that 3x and this 3x. You see that? And what's the square root of 4? 2 and 2. So that's how you got the 2's to pop up there. So some students might be able to see that right away. Where if I know I have a perfect squares on my first and last terms, I know it's called a perfect square trinomial. And what's beautiful about it is you'll always see the repeated by if it's a perfect square trinomial. And so either way, even if you did divide and slide on it, you'll still get it. It'll just take more steps. Okay? So study E real quick. I want you to tell me what's different about letter E that we kind of haven't seen yet so far. Okay, there's a negative out front.
You can divide them all by 3.
Very good. And this is important, guys, to recognize. Okay? See, a lot of times what students want to do here is they say, hey, I'm just going to multiply negative 36 times a negative 15 and make a huge number. See, if I have a greatest common factor, I want to pull it out first. Okay? So let's study those three numbers. And I want to ask yourself, what's the greatest common factor between those three terms? All right, so a lot of you are saying what? 3? 3 would work. Now, here's a little trick you got to keep in mind, guys. See, you always want your A value to be 1, or a positive number. So instead of 3, could I pull out a negative 3? Yeah, it's just dividing a negative out of it. It'll just manipulate your equation to look prettier. So what we're going to do is we're going to jot down our GCF was 3. So we're going to take out a negative 3 out of the entire thing. And just leave the other stuff in the parentheses. Okay? So what happens here is, let's produce what's left inside. See, if I divide this guy by negative 3, what's my first term become? A 12x squared. So now it's a positive LC. Okay? What's my next term become? A negative 16x. And then what's my next term become? A plus 5. Very good, guys. See, that's important to recognize is, hey, there's my GCF out front. Now I produce an easier try inside to work with. Okay, and that's the most common mistake you're going to see when students do this. Is a lot of times they want to just do the AC real quick without recognizing the GCF's going out front. Okay? So now we produce the inside that we can do the exact same method with. So you leave the negative 3 out front and just focus on the inside. Okay? So let's focus on that. Do divide and slide in the middle, or in the insides of it. Okay? What's 12 times 5, guys? 60, right? So we're going to rewrite that the middle, the insides as x squared minus 16x plus 60. All right, we're all watching that carefully? All right, what factors of 60 make negative 16? Very good. So I factor that as a general try. 10 and 6. The only way to get negative 16 with those numbers is to make both of those what? Negative, negative. All right, we're all following along there. And then what's the next step? Divide by what? See it? See, I multiply by 12 in the beginning. So what do I do at the end? Divide by 12. This is where you have to be careful, guys. So we're going to circle those last terms right here. We got to really make sure we're reducing correctly before we slide. Okay? What's 10/12 reduced to? Take a 2 out of each, right? So I'm left with 5/6 on that guy. What's 6/12 reduced to? 1/2. So it turns out you're sliding both of these, right? See how 6 doesn't come out of 5 evenly? So where does the 6 end up? In front of the x. So what's our first by look like? 6x minus 5. Very good. Okay? See how 2 doesn't come out of 1 evenly? So the other one would be 2x minus 1. Very good. Don't forget, what did we do in the beginning of the problem? Yeah, so we're going to put that -3 at the end. Just put it out front of that thing. So this becomes our factored form, guys, right there. Oh, I want you to see that sometimes, and notice, what form is this guy in? No. It's in that's your intercept form. Okay? So keep that in mind. So you generated the intercept of it. Where the A value is -3. So tell me this. If you were to graph that parabola, what direction would it go? Very good. To find the x-intercept, you have to take each of these 5s, set it equal to 0 to solve for the x-intercepts. Okay? So keep that in mind. All right, look at letter F with me here. This is important to see here. Is there a GCF? 16 and 36. Ooh, all right, we'll talk about that too in a minute. Let's pull a GCF out first, though, guys. Always pull your GCF out. So 4 comes out of both. Very good. So let's do that. We'll put a 4 out front. Okay. Tell me what's left inside. A 4x squared and a what? A 9. Bingo. See, always pull the GCF out first. See, now I got this stuff inside. Now, I want to see if you guys were picking up on it. See, this stuff inside. Is there any B value? There's no B value, but there is a what? What are the factors? And this is tricky, guys, because what you're going to see here is what are the factors of 9 that make 0? Yeah, so let's do this correct here. So let's write our 2 by's. All right, so you know they're going to be 3 and 3, right? And one's going to be plus, and the other one's going to be net. So you know that's what's going to go on the end, right? Now, how do you split this guy up? Yeah, see, that's a perfect square. So this is going to be 2x and 2x. All right, so what you got to recognize is actually what that's called is a difference of perfect squares. Every once in a while, you'll see 2 perfect squares subtracted, and you can just square root them and get your factored form. See, what's the square root of 4x squared? 2x and 2x. What's the square root of 9? 3 and 3. Right? So recognition is the key, and I want to jot that down in your notes. This thing right here is called a difference of squares. That's a special type of polynomial where it could still factor into its parts. We got to square root them. Okay? So our answer would be those 2 with 4 out front. Okay? All right, study letter G real quick with me. And I want you to tell me what's our GCF here. 4. So we're going to pull a 4 out front. Very good. So what's left inside? X squared minus 1. Bingo. Now, here's something we got to see now. Okay? This thing, are those perfect squares? Is x squared a perfect square? Yes, let's factor it. So you got x and x. And what about 1? Is 1 a perfect square? Yeah. What are the factors of 1? 1 and 1. What do the signs have to be? To make a negative, multiply back to a negative 1. Plus and minus. Alright, so this is another classic example of sometimes the insides produce a perfect square, difference of perfect squares. Write this down, guys. A difference of perfect squares looks like this. A difference of perfect squares is a squared minus b squared as a polynomial can be factored into a plus b times a minus b. That is important to remember, because every once in a while that pops up. Okay, that's our factored form of that difference of perfect squares. Okay, where you wouldn't have to do this divide and slide method if you recognize that. Okay, so that's crucial. That's crucial. All right, flip her over. Let's take a peek at a few more. We won't do all of these. We'll take just a handful together with you guys. Okay, so we're going to take a look at A, and let's do B together for sure. I want to model those. All right, here we go. What's different about the directions? What do you guys notice? So now they're telling you to do what? So now they want the x-intercepts. So we have to factor using our divide and slide method, or GCF, first, to produce the x-intercepts. All right, so here we go. Left side, there's no GCF. So we're going to use our what method to solve this thing? Divide and slide. Here we go. So 2 times 21. That's 42 on this side. Ailey, make sure you're following along here. Okay. All right, factor the left. What do we get, guys? It's factors of 42 that make a negative 1. 7 and 6. What's the only way to get a negative 1 from those numbers? Negative 7 plus 6. Bingo. All right, now we done? No, we multiplied by what in the beginning? A 2. So what do we have to do at the end? Divide by 2. Very good. So what you're seeing here is that method, guys, is helping us solve now. Okay, so notice we get, where does this 2 end up on this by? So you get 2x minus 7, not plus, minus 7. And then 6 divided by 2 is what? So then the other one's just x plus 3. See, we factored it into its intercept form. Now what we do is you take the parts and you set them equal to 0 to get the actual x-intercepts, just like we did on Monday. Okay? Let me show you guys what that looks like. You're going to get 2x minus 7 equals 0, and then x plus 3 equals 0. Okay? Well, which one's easier to solve? So what's the answer for that one? Negative 3. So that one's easy. Now, this one, you got to add 7 over first, and then divide by what? So what's our answer? 3.5 or 7/2, right? So if you think about it, if I add 7 to both sides, 2x equals 7, divide by 2, you get 7/2 for your other x. So what this means is our 2x intercepts, or 2 solutions to the equation, would be negative 3 and 3.5. Okay? Or 7/2. Are we seeing that? The divide and slide method is just factoring, guys, under this specific condition. Okay? Very important to recognize. Let's do C first before we do B, because I want you guys to see a connection. Okay? There's a connection here that we want to make sense of, all right? Is there a GCF on the left side? 7. Pull 7 out front. Okay. All right, help me out here. What's the inside's going to be? 2s squared minus 3s. Very good. Okay. Actually, could I also pull an s out? Yes. Yeah, so we're going to change this. We're going to put a 7s out front. Okay. How does that change this guy? 2s, cross off the square, minus what? Minus 3. So there we go. That's actually even better. So remember, if they both have an s in common, you can put an s out front too. So your answer would be very simple, guys. You take this part and set it equal to 0. And then you take this part and set it equal to 0. So when I have 7s equals 0, what's s? S is going to be what? 0. So that's one answer. See, this guy, when I have 2s minus 3 equals 0, can you guys do the algebra in your head? Bring the 3 over and then divide by 2. So what would it be? 3 halves, right? So notice s would also be 3 halves here. So there's your two answers. Okay? So keep it in mind, guys. See, this was just GCF approach. Alright, we didn't have to do divide and slide. One other type I want to model here before we rock and roll here. Look at letter B with me. Okay. What's different about letter B? There's 5 parts. Very good. So we got to set it equal to what? 0. Here's what we have to recognize. Okay? You got to bring everything to one side. 0 on the other. So strategy here, bring the 6x to what side? The left. And bring the negative 12 to the left. Bring both of those terms to the left side. Alright, watch this, guys. Do 2 algebra steps in one. So minus the 6x and add the 12 to the left. Okay, we're going to line it up on their like terms on the other side. So now I have 4x squared on the left, negative 24x on the left, plus 36 on the left, equals 0 on the right. Does everybody see what we just did there? Yeah. See, now we've established a trinomial that we could factor to solve. Okay? Is there a GCF on the left? Out of those 3 numbers, guys? 4. So put a 4 out front. Very good. Tell me what's inside, guys. So x squared minus 6x plus what? Plus 9. Bingo. Okay? Now, the insides of the parentheses is a try where 1's out front. So we don't need to do divide and slide, do we? We just do the general factors now. What are the factors of 9 that make 6? 3 and 3. Alright? So what we got here is 4 out front, our 2 buys, double buys, 3 and 3, and what are the signs? Minus, minus. Now, when you get to this step, okay, you see how the 4 doesn't have a variable attached to it? So you don't set that equal to 0. It has to have a variable like an x on it to set it equal to 0. So all you do is you take these 2 pieces and set them equal to 0. So what's x going to be in this case? 3. You only get one answer. You don't write 3 twice. You just write it once. Okay? So here's what we need to understand, guys. Real quick before I let you loose here. Okay? What would I do in a situation, in example 3, where they tell you to find the zeros? See, what would I plug in for f of x? 0. And g of x? 0. So it becomes the same types of problems as what? As the ones above. Okay? Are we seeing the process? All right, give me a finger count. I want to see where we're at. It's a tough lesson, guys. It's a tough one, but once we get a hang of it, I think we're going to get there. You doing okay? All right, sounds good. All right, here's what we're going to do. For